I'm Jeff Nelson, and I'm proud to be able to say that I'm the chairman of the physics department at William & Mary. And I'd like to welcome graduates, parents, siblings, grandparents, and other guests to the physics graduation ceremony. So this is an awesome occasion that we're gathering for to celebrate all of the accomplishments of these incredibly talented graduates. Before I turn it over to Professor Dudek, our guest speaker, I'm going to say just a few quick things. So first, let me say that we would have loved to have held the ceremony out on the beautiful lawn outside a small hall with the trees all around us and the breeze blowing. But speaking as somebody who's wearing 20 pounds of plastic robe and a felt hat, that wasn't going to work very well. So we moved it in here. And so hopefully, even though it's a little bit of a cozy confines here, we can still make the celebration be a magnificent one. The other thing is, being able to be here together as a group. And as Professor Dudek will talk about, COVID obviously has impacted the education of all of these students. But it's our first graduation that we've been able to have in person in 3 years. The last two have been by video. And speaking of a parent of a graduate of 2021 from another institution, where I got to sit in an ACC scale football stadium to watch 200 graduates socially distanced across the entire football field, not touch anybody during their ceremony. This is going to be better. Okay. So just a comment, because of the transition and things, masks are obviously not required at William & Mary anymore. Feel free to wear them. We do have extras in the back if you decide that you want one. Feel free to raise a hand and we'll get one delivered to you. And I think I'll save the rest of my comments for a little bit later. But we'll go ahead and first of all, so we have many of the faculty of the department hanging around in the back of the room. Could you wave and introduce yourself going around the room? I do know them all, but anyway. So Dr. Ran Yang, Dr. Irina Novikova, Dr. Eugene Mikhailov, David Armstrong, Seth Aubin. Who's behind Seth? Okay. It's Keith in the robe with, dressed up. I see Chris Carone. I see Bill Cook. I see Tricia Volley. I see Mark Scher. I see Justin Stevens, Todd Averett, Kostas, and Josh Ehrlich. Am I missing anybody? Wave if I didn't. Oh, Bill Cook, okay, in the second row. So anyway, a good representation of our officers of instruction.
Thank you very much, Jeff. Can everyone hear me okay? Good. So it really is a pleasure to be here today to celebrate the graduation of William & Mary physics class of 2022. And certainly this is something worthy of a celebration. William & Mary physics students are, in my experience, a singularly impressive group of people. The drive and curiosity continues to impress me, certainly, and allow me to illustrate with a short anecdote. For 10 years before I came to William & Mary, I taught at another university in the state of Virginia. As is common for every undergraduate and graduate class we teach, I offered an hour or two of office hours each week when students could come and ask questions about anything that was being discussed in the course we were doing. And while I continued to offer them, attendance was essentially zero, and it became to be a very useful time to get caught up on grant paperwork and boring administrative emails. And then I came to William & Mary, and naively, I thought it was going to be the same. But I was very wrong, and I found a new problem to be solved, which is how do you fit 8 or 9 eager students into a 12-foot by 12-foot office? Plus, my grant paperwork is now always late. But this particular group, curiosity and drive, has not been the only skills demanded of you. You've had to be more adaptable than most. Halfway through a semester of regular in-person classes, you had a global pandemic dropped on you. And you were forced to go home and receive your classes online from faculty members who often had little or no prior experience of teaching in a virtual format. But you adjusted, and we all got used to seeing each other surrounded by Zoom windows. In fact, maybe even now you're not adjusted back to the real world. Maybe you'd be more comfortable if I gave the talk like this. What, am I muted? So, a prop gag, I can't believe that worked, okay. An undergraduate physics degree is a challenging thing to obtain. A lot is expected of you. You start with a broad but shallow set of survey courses, which it's worth noting many non-physics majors report to be some of the hardest classes they take. But that's just the beginning. After that, you're expected to pass classes in all the basic fundamental theories in classical mechanics, quantum mechanics, electromagnetism, thermodynamics, and all of these theories expressed in terms of rigorous mathematics, which we also expect you to master. Plus, if that weren't enough, you have to master the necessary experimental tools in our lab classes. Something which I never did, but that's by the by. But then just when you think you've got the hang of classes, it's time for research. And this is a big jump. Because ultimately, classes consider situations where the answers are known. And it's somewhat like being a train engine. Track is laid down by the professor, and if you can just keep going, you will reach your destination. But research is off the rails. The answers aren't known, and you have to find a route through an uncharted territory. And this can be daunting. But we hope that the train ride through your classes showed you what the train's like, and you were ready to set out and find a research destination. Now, our undergraduates have had their first experiences of this in the form of their senior theses or in other work in our labs. And you'll hear the wonderful titles of the projects later on. And you can feel very smug if you understand more than half the words in those titles. But we also celebrate today this department's PhD graduates, and they've been on a real journey of discovery and research, having typically spent around 4 years working on a single in-depth research project. And they now find themselves, in many cases, quite possibly in the position of being the single person in the entire world who knows their small corner of physics better than anyone else. And that's certainly worthy of a celebration. So what has a physics education given you? Well, if physicists are unsuccessfully trying to appear cool at parties, we say something like, oh, nothing short of the basic rules that are followed by the universe and everything in it. You know, nothing special. But really, we learn the tools needed to understand physical systems that start from the smallest particles of nature through atoms, through systems of condensed matter, through plasmas, all the way to the large scale structure of the universe. But more practically still, we hope that you come away with an enviable skill set, a skill set containing lab techniques, electronics, computer programming, but also tools in mathematics, statistics, analysis of data, presentation skills, both verbal and written. And I suspect many more still universally applicable skills. Perseverance, resilience, and a rational and analytic approach to problem solving and assessment of evidence. So it's not easy to get through a degree of any kind, be it an undergraduate degree or a PhD, without outside help. It might be moral support, it might be practical help or financial assistance. And for providing these things, the faculty would like to offer our thanks to all of you who have supported our students during their time here. So that's thanks to parents and guardians, siblings, partners, friends, and whoever else. So thank you. The faculty would also like to thank our students directly for keeping us on our toes. Your curiosity and insightful questions challenge us to think about our subject in new ways, and ultimately this makes us into better physicists. So whatever you're planning to do next, be it graduate school, work in the real world, or even just a well-earned rest, the faculty and staff of the physics department wish you well, and we look forward to hearing about your future successes. Thank you.
So just a couple things before we get into the main game. First of all, most of you already went to a ceremony and you've already done the tassel thing, but we're going to do it again. Get it over on the left side. So mine is attached on the right. I thought that was the way it's supposed to be. It's left to right. Isn't that it? Is it right to left? Okay. Well, pretend I'm mirror imaged. Okay. And I can't do that. So anyway, because mine's attached. Okay. So, so the internet said it was opposite for high school and college, but anyway. But guess what? It's my first one of these. So Professor Dudek addressed the elephant in the room, the idea that during this pandemic, we were doing classes where your journey to class was get out of bed, walk to your desk, open up the laptop. And we did that for far too long, for far too many classes, of course. It was nice that we were able to have a few classes that were in person, some of those lab classes, some of those smaller classes. But if you're like my son when he was going through this, that research time, allowing you to connect with somebody and a few different people in that more intense environment was one of the ways that you rebuilt a connection with the institution. And it's one of the things that we do want to honor in this ceremony by reading out all of the titles for all of the research so that we can hear about all the impressive things that everybody's been working on along the way, because that becomes this fundamental reconnection that we had over the last year, which at least for me was a meaningful transition back to something like what it looked like in your freshman year. So we'll get going with the ceremony here before we do a wrap up. So the logistics of this now rather tight space are going to be interesting. So we're going to do by row. And if we can line up in order, starting with the front people here with Steve and then wrapping around towards that wall, we'll do it in groups. And then we'll go through the diploma. And I would say, something. Graduation ceremony. But I think it's a really special thing that they go through the work to be able to actually with the real Greek honors and everything else that goes in this. So know that when you're taking this, take care of it because it's the real thing, don't lose it. And in that hustle of moving out and everything, make sure it ends up somewhere special. Or it'll be like mine was, in the closet and put it across. So can we start by having the graduates line up and then Steve on this end and then everybody going back and we'll go through. And so what we're going to have you do is walk in front of me. Professor Dudek will give you your diploma and shake your hand, and then we'll cycle around. But rather than going back to your seat because you'd get in front of everybody, we'll just have everybody accumulate on that side and then we'll sit back as a row together. Does that make sense? Okay, cool. You didn't know that there was an exam today, right? You had to alphabetize yourself. One more sorting algorithm that we had to study along the way. Okay, so we're going to start off with the undergraduate degrees and then we'll recognize our graduating graduate students. So first of all, Young Ho Bo, who's I all know as Steve, a BS in physics, an EPAD track, and mathematics, summa cum laude. His thesis was design and specification of the anode plane assembly epoxy printer for use in the Fermilab's Dune project. So Jacob Miles Brotman Nahas, honors physics EPAD, advisor Ran Yang, cum laude, listening to nature, translating plant action potentials and environmental characteristics into music. Sophia Cameron Brown, honors, BS in physics, advisor Professor Novikova. Thesis was optical fiber linked magnetometer employing artificial intelligence for magnetic field measurement. Christian Cusack Nelkin, magna cum laude, physics EPAD, advisor Cook, DC pulsed plasma immersion ion implantation. So you, Derek? Okay, so Derek, oh, okay, is not here. Okay. And then Caitlin is also not here. Okay. Yep. That good?
No, I'm there.
You're Derek? Okay.
It should be C. Kraus. Okay.
Gordon Jameson Kraus. Okay, and I just missed a space. Sorry. Summa cum laude, honors, physics and government. A study of transport in the SOL regions of tokamaks, SOL region of tokamaks, with Professor Morton. No, Michael? No? Derek. Yeah, okay. Derek Dietz, advisor Bill Cook, cum laude, DC pulsed plasma immersion ion implantation, physics EPAD. Caitlin is unable to be here. Caitlin Michelle Dultz, BS in physics, advisor Josh Ehrlich, the classics of classical mechanics and analysis of Isaac Newton's Principia. Then also unable to be here is Destiny Des, as we know her, Dozier, BS EPAD, Professor Ran Yang, preclinical development of a smart video Lorentzianoscope. And then celebrating with chemistry today, instead of physics, but anyway, Tidwan Batiste Dustin, physics and chemistry, advisors Kidwell and Armstrong. Physics thesis was investigation of energy relaxation pathways in the A sigma NOCO cluster near dissociation. And Anthea Elaine Epson, PhD, BS in physics, EPAD, Professor Ran Yang, listening to nature, translating plant action potentials and environmental characteristics into music. And then Derek Fong, BS in physics, advisor Nelson, prototype circuit board production and quality control for the Dune detector anode plane assemblies. And Kelly Marie Fernandez, BS in physics, advisor Kordowski, studies of the impact of near detector measurements on systematic uncertainties in the Dune oscillation analysis, magna cum laude. Seth Aaron Neeson, honors, BS in physics, summa cum laude, advisor Mordick. Measurement, the method of protecting satellites from solar energetic particles using chaotic magnetic fields. And Michaela Rose Huffman, summa cum laude, BS in physics, advisors Sharon Singer, investigation of tertiary impact cratering in relation to impact physics theory. Okay, now we'll do the first of our great shuffles here. If we can have everybody in the front row back to their seats, and we'll get the second row to line themselves up similarly. Jordan. Okay, cool. Okay. Jordan Elias Kaseski, BS in Physics EPAD, Advisor Ran Yang, Development of the Video Laryngoscope with AI-assisted glottis, bounding, and automatic recording. Ouyang Lee, Advisor Chris Monahan, BS in Physics and Math, Chiral fermions and domain walls in lattice gauge theory, summa cum laude. Jiahui Li, honors Physics and Mathematics, Advisor Professor Novikova, an atomic magnetometer based on nonlinear magneto-optical polarization rotation, summa cum laude. And then Yaquan Cordelia Lee, BS Physics and Math, is celebrating with math today, but worked with Professor Organos, had Armand, Gate, Quantum Image Recognition Theory and Experiment, and summa cum laude. Am I missing? Okay. Okay, there you are. Morgan Elizabeth Langston, honors BS in Physics, Advisor Professor Aben, coplanar waveguides for microwave atom chips, cum laude. Congratulations. Then Quan Hui, honors Physics and Philosophy, Advisor Carone, non-local Lorentz violating modifications to quantum electrodynamics. Then I have Josh George O'Kane, honors BS Physics. You have to tell me what DSCI is.
Oh, data science.
That's data science? Okay, I thought they called it data. Anyway, cum laude, I learned something. Development of convolutional neural network for particle identification in the GLUOX Dirk detector, Professor Justin Stevens, cum laude. Then Elise Therese Palmer, BS in Physics, advisors. Good. I need a big thing to mark off, I guess. Well, we'll continue. Okay. BS in Physics, advisors Westholtz and Aben, utilizing blinking dynamics for multiplexed super resolution imaging. So, Caitlin Phillips Murat, BS in Computer Science and Physics, advisor Mikhailov, automating mode detection in quantum imaging, summa cum laude. I'm back on track, Michael. Cool. Michael T. Parker, BS Physics, advisor Todd Averett, alkali line widths under high temperature and pressure of helium-3, summa cum laude. Alec Keenan Pixton, BS in Physics EPAD track. Professor Bill Cook, DC pulsed plasma immersion ion implantation. Congratulations. Stephen Carl Wimmerus Rosner? Rosine. BS in Physics and Economics. Advisor Seth Aubin. Progress towards microwave manipulation of micro objects, cum laude. Tyler Schroeder. BS Physics, Math, Advisor Josh Ehrlich. Cosmological implications of stochastic quantum gravity, summa cum laude. I wrote too small. Sindhu Eshu Shanmugadas. Close? Close. BS in Physics, Advisor Seth Aubin, measuring the magnetic and electric fields of a microwave lattice for atom chip development, summa cum laude. Noah Gregory Shanton, BS in Physics, Advisor Professor Monahan, searching for new physics with B sub S meson decay, summa cum laude. Congratulations. Okay, let's do the shuffle. We'll get the second row back in their seats and the third row lined up. Okay. And then Jacob, right? Okay. Jacob Scott Silliman, BS in Physics, EPAD track, Advisor Bill Cook, Pulse DC plasma immersion ion implantation, summa cum laude. Rihan Siraj, BS in Physics, Advisor Saskia Mordick, diagnosing magnetic reconnection in simulations of tokamak scrape-off layer turbulence. Percival James Skolsky, yes, Physics EPAD track, advisors Professor Fry and Gong, design and development of a UAV mounted autonomous water sampling payload, magna cum laude. Jack Oliver Slater, BS in Physics EPAD track, advisors Dr. Frey and Gong, design and development of a UAV mounted autonomous water sampling payload, magna cum laude. Thomas Francis Sommer, BS Physics EPAD track, advisor Ran Yang, development of a video laryngiscope with AI-assisted epiglottis bounding and automatic recording, summa cum laude. Person Melville Stillman, BS Physics EPAD track, advisor Ran Yang, development of a video laryngoscope with AI-assisted epiglottis bounding and automatic recording, summa cum laude. Alexander Michael Tyrella, say it for me. BS in Physics, advisor Novikova, development of a vector magnetometer based on electromagnetically induced transparency and 87 rubidium 87 atomic vapor, summa cum laude. I have more names than I have people. I'm sorry. Okay. Carrie Ziyun Wang. Developing software for controlling an ultra-cold atomic apparatus, Professor Seth Aubin, magna cum laude. So, Jaru Eve Zhu, advisor Chris Monahan, development of a better procedure for lattice data analysis, cum laude. So, and we've got one more, Han Tao Yu, BS Physics and Math, advisor Bill Cook, ANSI, AISI 1020 low carbon steel outgassing analysis, summa cum laude. So congratulations to all of you on your bachelor's degrees. It's a remarkable accomplishment. We'll spend a brief minute recognizing the graduates that are here. We have, I see Matthew Knass, who's one of our master's students in the program. Can you stand up and wave to everybody? So our master's and PhD students just had their big ceremony in the basketball arena moments before the ceremony. So it's a double graduation day for them and a double honoring. But the diploma part of the ceremony happened in that activity. So in addition, we have 3 of our PhD students that are here. So we've got Archana Radhakrishnan. Thank you. And part of the reason why we have 3 of our PhD students here, even though there's over 10 on the list, is because PhD graduation is a little different. You defend when you defend, you turn in your thesis when you turn in your thesis, and you get your next job as soon as you can. So most have moved on to somewhere else. So we have examples of, for example, Amy, who defended last month, is now in Hungary starting her postdoc. So probably not going to make a trip back here for a graduation ceremony when you've got the future that you're looking forward to. So anyway, the future's there. And then for summer graduates, we have Luis Alberto Zueas Reyes. And then we have Richard Rexo Mojo. So thank you for coming and celebrating with us for a second celebration. I guess you didn't get enough already. So one bit of business. When I'm done talking, we've had the applause and all of that sort of thing. We have one mode of business for our graduates, which is we're going to take them all out to the steps out behind the lecture hall. And we're going to get a picture of all the graduates together in a big group shot. And we'll ask that the parents not get up so that we can try and do that in an orderly way. And we will distribute those photos on the website for graduation. And then feel free to, at that point, take those individual photos, mill around, talk to the people that you want to talk to, and get those group shots out with the beautiful crepe marbles outside and that sort of thing. Although not too long outside because we don't want to melt. So graduates, you've experienced and overcome an unprecedented number of challenges as we've worked together to get our way through an ever-evolving modes of teaching delivery, as well as navigating the pandemic together. We've learned how to look at challenges in the world and recognize how you can dissect them with your training of mental toolbox items, so that any problem that you see around, you can break down to its elements, find the underlying dynamics, work through a plan for a solution, solving problems that are analytic, that might look like hopeless messes of Greek symbols, even to you a couple years ago, right? Parents, you should go look at some of those homework assignments. You'll see a mess of Greek. If that happens on cleanup for move out. But beyond doing lots of homework problems and finding that one subtle mistake in that really complicated last electronics lab, you've defended the results of a year-long honors research project to your professors and to the department. And you've documented that, and it's archived on the library for future reference as we move forward in our studies of physics. And in almost every case, those theses are directly involved with something of research interest to one of the faculty at the institution, making progress in a way that they wouldn't have been able to make without leveraging all of your effort, your intelligence, and your perseverance to make steps forward on all of that original work. And like Professor Dudek said, that's not a laid path to move forward. You know, the world is full of two kinds of people: those that can extrapolate from incomplete data, so anyway, I like that one. So I want to say a quick thing to the EPAD students here. It's a program that's near and dear to my heart because I've been involved in it from the beginning, although a little less in this year's class. But you're the third class of EPAD graduates. You were the first ones that have the opportunity to, as a freshman, say, EPAD, that might be interesting. I could go do that. All of the ones before you had to actually rework their degree plans to try and accommodate it because it came along midstream. So we're happy to have you be the first ones that have run through the program as we intended it to be. So congratulations for being pioneers in the program and helping pave the way for the program and helping us understand how to evolve it as we move forward. So thank you to the EPAD grads. So we had a little bit of this before, graduates. We know we had a role in helping get you through to your degree, but we also know that everybody that's out here in the audience behind you had a role in getting through to your degree. If you wouldn't mind, could you stand up, turn around, and give them all a round of applause? We as faculty will just say our heartfelt thanks for all the support that you've given to these fine young scholars, both in their time before getting to William and Mary and throughout their time. We know they couldn't have done it with all of that support, especially through these unprecedented and trying times. So again, thank you. So, from whichever side it was supposed to be, now is the time that we should move it to the other side. So graduates, congratulations. Go forward, have your picture taken, and then go on and conquer the world. Thank you.